Hi, I'm Menahi Shayan. I'm part of the engineering team at Zenduty, which is an end-to-end incident management platform. So we basically help companies minimize their downtime and meet their SLAs. If that went over your head, just know that when your favorite website goes down, send them to us. They won't go down as much. All right? And I'm going to be talking about building production-grade monorepos for React and React Native. So it's become obvious that JS has evolved far beyond just web apps that it was originally intended for, and is now building native mobile apps and desktop apps. These are great platforms to build for, and it is incredible that we can do this through a single JS code base. So how many of you have built React Native apps? Yeah, it's a good number. It's a good number. And how many of you have tried building the same project in both React and React Native, or at least similar projects, right? Maybe you start off, yeah, that's a lot. So you start off as maybe a React app, and you decide, okay, this would be much better if we have a mobile app as well, right, or a native desktop app. So it's companies want to do this, devs want to do this, right? It is in the best interest of everyone to actually build for multiple platforms in a single code base. The code base, if you will. Okay. More often than not, when you actually get into this, most people use a single code base for all of their applications. As long as it is a single product, a single code base builds on all of your platforms, be it React, be it React Native, be it for mobile, be it for desktop, right? When you do implement an architecture such as this, you will eventually run into problems of how do you structure this? What should the structure look like? So you will not come into such a problem initially when you're setting it up, right? Initially, it's just, yeah, create React app, create React Native app, and like you're good to go. But like Pranav said before me, the real challenges only come up a year later when you actually scale, or maybe 3 years later when you scale exponentially, right? That is when you actually start to think about problems like these. What should be the right architecture that we use? How do we make the dev experience as simple as possible? How do you make code changes as quick as possible so that you can make releases as fast as possible? How do you manage scalability, the current scale and the upcoming scale? Things like these actually end up boosting your productivity. All right. So we were plagued with this question as well at Zenduty, and we considered a lot of approaches. Let me discuss some of the traditional approaches that you'll find online and approaches that we actually considered, right? So one approach that people use to have React and React Native projects in the same code base is the same folder, but you'll probably have different suffixes. So as you can see, a very difficult task is centering divs, as many people agree. All right, it is a running meme, but ideally make a component for it. Don't, that's a joke. But most people will, let's say, have a .web and a .native or a .android and things like that. So you would have a single folder, and you would just have different suffixes, and you would pick up the respective files, right? This would leave your code base largely unnecessarily interweaved, right? It's not scalable for large projects. Or maybe entirely different folder structures. Your mobile app is in a completely different folder, your web app is in a completely different folder. There is strong separation there, but how would you share code, right? Let's say you've got a massive API layer that is common code with both web and native. How would you share this? You would have to have redundancy. The same file would be in multiple places. Now imagine someone made a very big change to that file, right? In only one of the places. Now what do? You're responsible for carrying over this massive change onto the other file. That it's just not scalable, right? Another option that we have seen people use is conditional imports. So for React, you would just import the React component, and for native, you will import the native component manually. Every single file would have lines of just conditional operators. This creates clutter. You have Git submodules. So Git submodules can work in some cases, but they need to be implemented perfectly. Because how many of you have heard of Git submodules to begin with? Yeah, few people have heard of them. So what Git submodules do is basically they give you sub repos within repos. All right. So your native would be a separate submodule within your Git, and your web would be a separate submodule. They would each have their own version control. You would each be doing their commits separately. These commits would be separate, and the entire root workspace would also have its own repo, which is committed separately. So listening to that itself sounds very tedious, right? And when you're working with large teams in parallel and working with a lot of branches in parallel, this can be very confusing. So what is a good alternative to this? What is an alternative that worked very well for us? Introducing Yarn Workspaces. Why is this so good? Yarn Workspaces allow you to use a single Git repo to manage all of the projects that you have, the shared projects within the same workspace. You have multiple projects within the same repo, and you can define them as your own separate custom packages. Just look at how I've used Zen/API here. I've defined my own API layer, and I'm sharing it across all of my apps. You can share code without duplicates. If there's some code that you would like to use in multiple projects, just define it as a separate package. And you can easily import them in all of the apps that you use. Yarn Workspaces have native support for dependency deduplication. Let's say you're using package 1 in both of your apps, and you have multiple node modules folders, right? So Yarn will automatically figure that out and not install package 1 multiple times, right? It deduplicates that and installs it only in the root workspace. Yarn Workspaces come with a ton of additional benefits, which is why it has worked really well for us. So now the question is how? How do you move an existing large-scale project to a monorepo? It's quite simple actually. You just get started with Yarn and you initialize your workspace. It's as simple as just defining your packages. All of the common code goes into something called a package, its own package per se, and you would just define it such as this. And after that, you can just import it in your applications. So let's say your web app is using your API, you just mark it there as a dependency, and you're good to go. That's all it is. Well, along with the fact that you will need to be doing some moving around, and how much moving around you will need to do entirely depends on how big your code base is, right? But that's the gist of it. Now, it's not all roses, right? What are some production grade challenges that we faced while moving a large code base to a Yarn monorepo? So one challenge that we faced is ensuring shared code compatibility, right? So when devs come in and decide to make drastic changes to the structure or the architecture, most of them tend to forget that a lot of this code was written 4 or 5 years ago, maybe decades ago. This is all legacy code that is still in production, but is running very well, so nobody touches it, okay? So there's probably even a comment there that says legacy code do not touch, okay? But legacy code and a lot of intertwined code, all right? So let's say, look at this hook, for example. So does anyone see the problem as to why this would not work in React Native? Right? You're referencing window.location, and that simply does not work on React Native. And things like this, you'll find a lot of tiny problems here and there that make it incompatible. If these problems are few and far between, your easiest and quickest approach to get to production is just have simple checks here and there. Right? Simple checks can easily avoid it, and you could have your native specific code over there. Just get them out of the way with some conditional logic. Another challenge that we face is handling deeply entangled code. Let's say this, for example, this is an actual scenario that we faced. So let's say you're trying to display a toast message, right? This particular file has code of React and React Native. They're both being imported in a single file, and there's no conditional logic in between. It's just the export that's changing, right? This is one example of deeply entangled code where it's incompatible. Let me tell you, so to look at this, understand why this is a problem, you first need to understand why is this incompatible, right? How many of you think that this would work perfectly fine in both React and React Native without throwing any errors here and there? Because you see, is native, return that toast, and is not native, return the other toast, right? Seems like magic? No, because this is when you need to look into how bundlers work. So you see that React Native toast import over there, right? Your bundler looks at that, it's going to try to find out its dependencies. And React Native toast is most likely using React Native, right, for UI and things like that. But the question is, what is React Native using? How many imports does React Native do? Because your bundler is also going to crawl the imports that React Native is making. And it is a lot that is incompatible with React. Your bundler will try to crawl all of these and build a map out of this, which will simply fail on web. So what do you do when code is so deeply entangled and you cannot actually make changes in the file itself? Just exclude what does not work, right? So let's say you cannot make any change to the toast file. You simply have to just exclude React Native from your Webpack. So what it will do is while building its map, it will just go over there and it will just stop building the map at the excluded dependency. Simple. So as long as you don't reference that component anywhere in your web app, you will have no compilation issues. Another issue that we faced was sharing linter and formatter configs, right? It is a DevX dream to have a standard linter and formatter config across all of your projects, across all of your apps, all of your components, everything. A single editor config, a single formatter config, right? But how do you do this in monorepos? How do you do this without writing the same ESLint config over and over again? Yeah. So a simple approach to this is just extending. Through monorepos, it is easier than ever to just extend the one config that you have. You just define it as a package, and you can just extend your proprietary ESLint config, right? So it's quite simple, very clean approach. Now, another problem that we faced was having TypeScript and JavaScript projects in the same repo. How many of you have worked with TypeScript? Yeah, a lot, right? So when you have large code bases, right, with multiple projects, you can't be sure that all of them will be written in TypeScript as much as we would like it. Some projects are just too tedious to move to TypeScript. So we end up having some projects in TypeScript and some projects in JS, right? So when you have this in a monorepo, how do you deal with it, right? How do you deal with shared dependencies and packages and all that? Before we address that, let's get the parsers and linters and formatter configs out of the way. Let's say you want to use the same ESLint config and prettier config and all of that in your ESLint JS project and your TypeScript project. How do you do that? It would be nice. It's a great nice to have for the dev experience. Well, it is as simple as inheriting it there itself. You can inherit your ESLint config in your TS config. You just import it, you just require it there, and you can spread it and build upon that. You can add additional TypeScript specific config right there, and you're good to go. You now have the same ESLint config, prettier config, type config. It's all the same everywhere across all your projects. Zen, that is DevX Zen right there. Now to address the elephant in the room. One of your projects is in JS, one of your projects is in TypeScript. What do you do to shared packages? Obviously, you cannot write them in TypeScript, right? Your compiler will just fail at that step. So they will have to be written in JS. But having your shared packages in JS and your React Native app in TypeScript it sort of reduces the efficacy of TypeScript, right? You would ideally want to have as much types as possible. Once you get into TypeScript, you just cannot stop having types. So what do you do there? A simple answer to this is JS docs. How many of you have heard of JS docs? Not many? Interesting. But all of you have heard of TypeScript, right? Yeah, so JS docs allow you to get types into your code without actually adding your TypeScript compiler and additional overheads that come with TypeScript. But at Zenduty, we took it even further. So instead of just having regular JS docs, we are actually importing types, d.ts files in JS docs. A lot of people do not know that this is possible. You can define your own d.ts files that are shared across your TS projects, and you can just import them in JS. You essentially have all of the IDE features of TypeScript, but without actually adding the TypeScript overhead to your compiler. Upon this, you can just add a TS check to your JS files, and you're golden in terms of IDE type checking without actually having TypeScript overheads. But again, in the world of monorepos, it's not all roses, right? There are some cases where you may not want to use a monorepo. What are these cases? Complex ownership structures. So I've been talking about having common packages that are shared here and there, right? But what if one of your packages were open source? Only your component library is open source, but your actual product is not open source, right? And they're in the same, what if they were in the same repo? That becomes very difficult to actually manage ownership, right? You cannot only expose a certain part. So complex ownership structures, partly open source code, things like these, monorepos may not be the right approach. Minimal overlap. Where most of your code is just not shared, right? Where one project and the other project are just too vastly different from each other. Cases where it's easier to move to React Native Web. So if you are using React Native Web, you will not have to use React directly, right? Because your single React Native project can actually export for web, mobile, desktop, native, all of that stuff. Using the same code itself. You don't even have to deal with React directly. So if your code base is still in its infancy and you have not yet built upon it too much, consider whether React Native Web is feasible for you, because that makes things a lot easier. Volatile, unrestricted merge policies. So let's say your code is really volatile, or let's say you have a lot of people pushing untested code where master can very easily break, right? You would not want volatile code in a monorepo. So the final verdict as to whether or not monorepos are right for you and your project entirely depend on a case-to-case basis. But if your use case matches anything that I've described here, or if the challenges that I mentioned seem interesting to you, you should definitely consider it. Thank you.